Okay, we just looked at how we could change the way an API was requested. We changed the results from 8 to 3. Now the first thing I'm going to do is just jump back into Fiddler, go to onBeforeRequest, and I'm going to comment out that little piece of code again which changed the request. And we'll save that script. We'll jump back over to the app, down into a car, and then back home again, and we should now have 8 cars again. Now I have a bit of a problem with the results here. I love the GTR, but the problem is I've already voted on the GTR. In fact, you can see me having commented just here. Now if I log in, we'll find that I cannot vote again. And we'll put in my same lousy password, log in, and of course I have no comment button. That is a problem. However, because I own the connection and I can modify the responses to the device, I might just be able to make another comment if I get a little bit sneaky in the way the API responds to the device. So let's jump back into FiddlerScript. And I'm going to go down to the onBeforeResponse event. And as I did before, I've got a piece of code in here, again, under Hack Your API First, and I'm going to uncomment this little piece of code, and we'll have a look at what it's going to do. So firstly, it's looking at the session where the response header exists and contains a content type of application JSON. So just for a little efficiency, it's only going to inspect content types that are JSON responses. Now after that, it's going to decode the response. So if it's gzipped, it'll get unzipped before going to the next step. That next step is a replace in response. And here's what it's going to do. It's going to look for this string. And this string is just a great big whack of JSON that runs all the way out down to here. And in fact, that is just one vote in the collection of votes. It's going to replace it with this, an empty string. In other words, it's going to find my vote in the response and remove it. Now we'll just save that. And before I go back to the app, let's remember what that response looked like. So there was the last response. Into our inspectors. We'll have a look at the raw response because it's a little bit easier to see the exact string that we just entered in FiddlerScript. And I'll scroll over. Here is our votes collection. And here's the string we're going to replace. Goes all the way out through to that terrible, terrible practice of putting the password in the string. So effectively, it's going to chop this out so the device won't actually see it. Let's have a look at what that does to our mobile app. So we'll go back to the home page. Now let's load the GTR again. How about this? I no longer have a vote. And because I no longer have the vote, the app is now allowing me to vote and comment. This is very advantageous because I like the GTR and I want to put in more votes. Now let's pause here a moment and I want to go back to the point I made in the earlier slides about trust. What we're seeing here is the app making a decision about authorization based on the response that it's received from the API. Now in this case, that authorization is saying if the user does not already have a vote in the collection, then give them the vote and comment button that you see here. So effectively, what it looks like is that we've just circumvented the control. Now, of course, we're only going to know if we've properly circumvented the control if the server actually lets us vote again. So let's give that a go. We'll go down to vote and comment, and we will enter. Aha, I can vote again. And we will now save that vote. Submit. All right, so this actually looks pretty positive. We're seeing it back in the app. But there's one surefire way of validating if we've actually been able to vote again, and that's to open up the app in the browser. So let me just drag that over now. So here's Supercar Showdown running in Chrome. That was the GTR just over there. So we'll go back to that guy, drill down, and here we go. There's the original vote that I excluded from the API when the response went back to the client. And now here's the new vote that I've just added again. Now clearly there are a couple of problems here. The first problem is that the rich client trusted the response from the API and made an authorization decision based on the data it received. Now that kind of is and is not a problem. So yes, it's a problem insofar as we modified the behavior of the client, but by the same token, if you own the device and you can control the response that the client receives, there's not a whole lot you can do about that, short of going down message authentication codes, which in this case is not really necessary. The underlying issue here is that the voting API allowed a subsequent vote from someone who already had one in the system. Effectively, the vote API trusted the client to do the right thing, and then we circumvented the controls on the client. So this goes back to an old adage that's often repeated in web applications, which is that yes, you should have client validation and client controls, and there are many reasons to do that, particularly when it comes to being highly responsive and being able to make decisions without necessarily going back to the server. But you always have to have the server-side control to complement that, and that's what was missing here. Now, of course, the other thing I could have done here is always just found out what the request pattern was to make a legitimate vote and then just reissued it over and over and over again, using something like the composer in Fiddler. That would also take advantage of the fact that the server wasn't validating this business logic of one user not being able to vote twice for the same vehicle. So there are a couple of ways that we could break this particular security control. But the real important thing here in the context of mobile goes back again to those opening slides. It's about trust. And in this particular case, no verification. You need to expect that that client is going to do things it wasn't designed to do, simply because the attacker can modify the way it communicates with the server. And that is a fundamentally important lesson in this course.